Okay, so section 2 are circles, finding arc measures. I think this is kind of an easier section. So we have, some more terminology with circles. So if we have, C for center, and then we kind of draw a couple radii or radius. So we have what's called a central angle. It's like the angle at the center. That's something that we'll use fairly frequently today. And really, I'll do that first. Okay, so we have what's called a minor arc, less than 180 degrees, major arc, more than 180, a semicircle is at 180 degrees. So this would also be using a diameter. Okay, so there's also like a, I don't know if it's a definition or it's not even a theorem, but excuse me. So let's say that this central angle, ABC, was 70 degrees. So when we talk about, we haven't really gone over this before, but when we talk about an angle, when we say, well, it's 70 degrees, well, what does that mean? It's measuring the opening, not how far it is from a certain point to a certain point, but just the, I don't want to say width because that's like a measurement that you think like how long, but it's what it's measuring is the opening itself relative to 360 all the way around. What's that angle measure? So the central, and here's like a key thing, the central angle is the same as the arc. Now this isn't saying how far is it from A to C. Okay, it's not saying, well, it's 70 feet. It's saying the degrees, the opening is measuring 70 degrees. Okay, and so the way that you would write that is you could say the arc, so it's kind of like a segment thing, but you just make a little arc, equals 70 degrees. Okay, so we'll get into, maybe even in the next section, let me check how, nope, it'll be later, how far it is from A to C. We'll do that in a different section. But the central angle equals the arc is like a really key component throughout the chapter. All right. So the other thing that you need to be aware of, so one, like when you see a dot like that, that's telling you that's the center. So which also tells you that T to R is a diameter. All right, so if we want to find the measure of RS, okay, so well, it tells us 110, so that's 110. Now some people like say, well, do you always, okay, so from R to S is like kind of like down or to the left, like do you always go that direction? No, you go the shortest direction. So if I said from R to S, I'm not going to go to the left or around like the long way. I have to go the shortest way. If it wanted to know how far is it from R to S the other direction, it would have to go like this. So when there's two letters, you must go the shortest way around. If there's three letters, then you have to go in that order. So I have to start at R, then I go toward the T and continue on to the S. Like I can't change directions. I wouldn't go down and under to the T and then backwards to the S. I go R over the top to T and then down to S. Like that's what it's wanting to know. So for that, well, nothing else is like marked. Well, that's okay. All the way around is 360. And I don't want this like RS on the bottom part. I want to go from R to T to S around the other part. So I would just do 360 minus 110. That doesn't look right. Is 250. So we can add arcs together. We can subtract them. Okay, so if I said RST, that means go from the R like toward the 110, go from the R to the S to the T. Well, R to T is part of a diameter, which means it's part of a semicircle, and that means it's 180 degrees. Okay, so you can add, you can subtract arcs, you can, all kinds of stuff. So the beginning part of your assignment is going to be just doing that. Name the red arc and find its measures. So, the naming would just be the letters and then like what's the degrees. Then the next section, identify the given arc as a major arc or minor arc or semicircle. Then find the measure of the arc. So some of them might just be the regular arc, and some of them might be like two of them combined or three of them combined. Again, you can add, subtract, whatever you need to do the arcs together. Okay, but you'll know the degrees or be able to figure out the degrees. Like on this one, because TR is a diameter, I can figure out, well, that other part's 180. If I wanted to figure out TS, I could subtract 180 and 110 and figure that part out. So again, you can just manipulate those as needed. Okay. All right, so like this finding arcs like stuff, that's kind of going to be hit on a lot more than the congruent circle thing. Okay. All right. Have a great day. Have a good Friday, and we'll see you on Monday. There is a couple theorems in here. So theorem 10.3 is congruent circles. So it says two circles are congruent if and only if the same radius. Okay, so if one circle has a radius that's 5 and another one has a radius of 5, they are congruent. It's the only like measurement that you could really like use. Okay, and so if and only if means if it says this circle is congruent to this circle, then you know the radius are the same. If it says, has two pictures and it says this radius is 8 and that radius is 8, then you know the circles are congruent. You can go back and forth with the information. You don't have to know one to know the other, like in a certain order. There's another one that, I'll write it down, but it's not like one that you can you'll find that when we get toward the end of the chapter, I'm going to give you kind of a list of theorems, and I'm going to eliminate some because you can figure them out. Goodness gracious, I can't write. Congruent central angles. So you can figure out some of the information, like this theorem is one that you can very easily know without knowing the theorem, just using kind of some logic. So it says in the same circle or congruent circles, two minor arcs are congruent if and only if their central angles are congruent. So it's just saying, like, so if we kind of draw an X, this is in the same circle, but so if it said this was 30 degrees, so that arc is 30 degrees, well, vertical angle, that's 30 degrees, and that's 30 degrees. Like, you can figure out that these arcs along the outside are both like 30, so they're going to be congruent because you know that the angles in the middle are congruent. So trying to like really memorize this theorem is information that I think we can kind of eliminate, so to speak, because with some very easy like logic, we know it's true. We don't need to like have it to use for other like things. So if you had two, circles, so if this radius was 5, that is absolutely atrocious. Not even close to a circle. Circle's really hard to draw like good. A little better. If it said, okay, that radius is 5, so okay, now I have congruent circles. Well, if that's 30, then that's 30, so the arcs are congruent. It's going to be fairly straightforward. But it's also talking about the arcs being congruent, but the distance will be congruent also. And we'll come back to that down the road. Okay, so your last set of like a few problems, it'll say tell whether the red arcs are congruent. So and then there'll be black circles, but then a couple of the arcs will be like marked off. Okay, so if they need to have the same central angle, and they need to be either in the same circle or congruent circles. So if you have arcs that are both 30 degrees, but one is in a bigger circle than the other, then the arcs are not going to be congruent, because then it is talking about distance like as well. Okay, so just the same circle or congruent circles. So if I change that 8 to a 10, these arcs are not congruent. They're both 30 degrees, but it's kind of like saying, you know, is it the same distance around a quarter as it is the same distance around a dime? No, but they're both 360 degrees. They're not the same because the quarter is bigger than a dime. Okay, so those problems are fairly straightforward. Just again, congruent circles, if there's two circles, they have to have the same radius, or in the same circle. If they're in the same circle, that one's a lot easier, but just make sure you hit that congruent circle part. Okay? All right, so the major component of the chapter